dear class 9ers. In the last class we have discussed the term thrust, pressure, the unit of pressure in the CGS and SI unit. Now today we will discuss two things. One is the factors affecting the pressure, and the second one is the way of increasing the pressure and reducing the pressure. So now pressure, when we discuss about the pressure, pressure equals to thrust divided by area. Okay, pressure equals to thrust divided by area, which we have discussed it. So pressure, the SI unit of pressure is Newton per meter square. Okay, from this definition, that is pressure equals to thrust divided by area. So the SI unit of thrust is Newton, SI unit of area is meter square. So therefore SI unit of pressure is Newton per meter square. So similarly, the CGS unit of pressure is dyne per centimeter square. So therefore the SI unit of pressure is Newton per meter square, or also written as Pascal, which is written as PA. And Pascal, now why it is named as a Pascal? Because it is kept in the name of a French scientist Blaise Pascal. Okay, name of a scientist. This SI unit of pressure is kept in the name of the scientist. So you can write it here Newton per meter square or Pascal. So therefore now when you define Pascal here, so since the SI unit of pressure is Pascal here, so I write it here 1 PA, 1 Pascal equals to 1 Newton divided by 1 meter square. Okay, so 1 Pascal equals to 1 Newton divided by 1 meter square. So let us define Pascal. 1 Pascal is the pressure which acts on a surface area of 1 meter square when applied a force of 1 Newton. So that means 1 Pascal, it is a pressure in which 1 meter square, in which the surface area having 1 meter square, you will apply a force of 1 Newton. So that depends as, that is known as the 1 Pascal. So the CGS unit of pressure also we have discussed it, and other units of pressure is also there, known as bar and millibar. Other units are also there, bar and millibar. These are the other unit of pressure. Okay. Now the atmospheric pressure. Now atmospheric pressure is measured in terms of level of mercury column in the barometer. Okay, in the barometer, barometer is the device which measures atmospheric pressure. Okay, and in barometer there is a liquid filled on it, and that liquid is a mercury. Okay, and the level of mercury, by seeing the level of the mercury in the barometer, okay, we can find the atmospheric pressure. So the normal atmospheric pressure at sea level is 76 centimeter of mercury, or written as 0.76 meter of mercury, or 760 millimeter of mercury. Okay, so in the three unit it has been given here: 76 centimeter mercury, 0.76 meter. So divided by 100, it becomes, to convert into meter, centimeter to meter, you have to divide it by 100, so that will become 0.76, and here you multiply by 10. When you multiply by 10, 76 into 10 will become 760 millimeter of mercury. So the atmospheric pressure can also be measured in terms of, expressed in terms of the height of the mercury level in the barometer. Okay. Then the other unit are also being used, known as torr, T-O-R-R. Okay, T-O-R-R. And this torr is kept in the name of a scientist known as Torrison. Okay, the other unit are also there, that is known as the torr, that is the unit of atmospheric pressure. Okay, the unit of atmospheric pressure is written as torr. Okay, unit of atmospheric pressure, and unit of pressure is written as Pascal or Newton per meter square. Okay, so similarly, the unit of atmospheric pressure can be written as torr, which is named after a scientist, that is Torrison. Okay, so that is the other unit. And 1 torr is equivalent to 1 millimeter of mercury. So 1 torr is equals to 1 millimeter of mercury. 1 torr is equivalent to 1 millimeter of mercury, and 1 atmosphere is considered as 760 torr. T-O-R-R. That means 1 atmosphere is equivalent to 760 torr. So now this atmospheric pressure can also be used, can also be expressed in a unit known as atmosphere. Atmospheric pressure can be used or can be expressed in a unit known as atmosphere. So it can be written as ATM, that is atmosphere. So atmospheric pressure can be expressed, okay, in atmosphere, or it can be expressed in torr. So 1 torr is equivalent to 1 millimeter mercury, 1 atmosphere is equivalent to 760 millimeter of mercury. Now the next point is here, factors affecting the pressure, or the factors affecting in which the pressure it depends. So now the pressure depends upon the surface area. Number 1 is the surface area, okay, in which the thrust is applied. Thrust means the force. Surface area in which the thrust is applied. And second one is the magnitude of the thrust. So pressure depends upon the 2 factors. One is the surface area in which the thrust is applied, and the second one is the magnitude of the thrust. Magnitude means the amount of thrust. Thrust means the force. So number 1 factor is depends upon the first factor is there, that is pressure depends upon the surface area in which the thrust is applied. So let us consider one example. You take a sand, okay, a loose sand, okay, just spread it on the floor, on the ground, and you just take a feet. You just put a feet into the sand. The feet will sink under the sand. Okay, the feet will sink under the sand. So next one, what you do is that you just lie it on the sand. You lie your entire body on the sand. First, you put only the feet on the sand. Your feet will sink under the sand. Then the second one is you lie your body on the sand. What you will observe is that your body will not sink. So from here, what observation you will get is that when you put your feet in a sand, okay, on the sand, your feet will sink. Now why the feet will sink is that the surface area is less. Lesser the surface area, more will be the pressure. Lesser the surface area, more will be the pressure. And second one is here, your entire body. Now you have lied your body on the sand. Okay, you lie your body on the sand. Now the surface area will become more. So when the surface area become more, so therefore the pressure will become less. So the first one is there, pressure depends upon the surface area in which the thrust is applied. Okay, so in both the cases here, the thrust which you have applied, the force which you have applied is same, because the weight of the body is same. Okay, when you put your feet on the sand also, your body weight is same. When you lie your body on the sand also, the body weight is same. Okay, so thrust applied is same here, but the pressure is different here. So that means the pressure is more when the surface area is less. Pressure is less when the surface area is more. Okay, so this is the first one. Second one is the pressure depends upon the magnitude of the thrust. That means more the force we apply, more the thrust applied, more will be the pressure. More the thrust will apply, more will be the pressure. Lesser the thrust will apply, lesser will be the pressure. Okay, so these are the 2 factors. Now let us come to the next point, the way in which the pressure can be increased. You can increase the pressure by reducing the surface area. You can increase the pressure by reducing the surface area of a body. Okay, now how you increase the surface area means, let us consider a nail. The one end of the nail is pointed. Now why the nail is pointed is that because it becomes easy to pierce the nail in a wooden plank by applying a less effort or less force. Because in the pointed end of the nail, the surface area is less. So when the surface area is less, by applying a less force, the nail can pierce into the wooden plank easily. So that is why the surface area can be increased by reducing the reducing the pressure. Understood? Sorry, reducing the area. Second point is there. Second one is there to reduce the pressure. So in order to reduce the pressure, you will increase the surface area. More the surface area, lesser will be the pressure. So another example is here. While constructing a building, okay, the base of the building or the base of the dam, okay, when the dam, hydro dam are constructed or the buildings are constructed, the base of the dam or the building are made broader or wider. Okay, that means when the base are made wider, okay, the pressure exerted by that building or the dam will become less. So therefore, it doesn't get collapsed. Okay, so when the surface area is more, then the pressure will become less. So when the pressure will become less, so therefore the buildings or a dam can withstand, okay, without any damage or without any kinds of damages. It can be withstand. So therefore, the next point is here to increase the surface into to reduce the pressure. In order to reduce the pressure, you will increase the surface area. When the surface area is increased, then the pressure will be reduced. Okay. So the example is by while constructing a dam or a building, the surface area, the base of the dam or buildings are made broader in order to reduce the pressure. So this way you can increase or reduce the pressure by depending upon the surface area and the amount of thrust which has been applied. So this is about the pressure. In the next class we'll come to the pressure in